Welcome back everyone, Patrick here, and moving on to another question dealing with limits at infinity. We got this complex limit over here. We got the limit as x approaches infinity of the square root of x to the 3 plus 7x squared plus the fourth root of 6x squared plus 16x to the 12 plus 8x cubed all over 5x squared minus the third root of 7 plus 5x to the 6 minus 8x to the 9. So looks complex, but it's actually not too bad, especially if you've been following along with the videos. I'm going to be using the exact same methods I've been using up until this point. So if you haven't watched the previous videos on limits at infinity, make sure you watch those before this one here. And if you have watched those, I actually recommend you pause the video and you try this limit yourself. The answer to this limit is 5. So if you do try it yourself, this is the answer that you should get. And I'd recommend, again, pausing it, trying it yourself. Even if you don't get 5, don't be discouraged. This is a pretty complex one. Highly doubt you're going to get anything more complex than this on your midterm or exam. But never say never. I never make any guarantees 100%. So what is the first step here? The first step is notice that we have a bunch of expressions with square roots. We got the square root, we got the fourth root, we got the third root. So what we want to do is we want to convert those to be in a format where we have two factors multiplied by each other, like I did in the previous example. So that's actually the first thing I'm going to do. So I'm going to work with this expression first. We got x to the power 3 plus 7x squared. So I'm going to do a bunch of side work first, and then I'm going to take the results of that side work and bring it back to that main limit. So dealing with this here, the square root of x to the 3 plus 7x squared, first thing you want to do, factor out within that square root x to the highest power, which is 3 in this case. If I take out x to the 3, take out x to the 3, what am I left with here? Well, this would just be 1 plus 7 over x. Because there's 2 x's, 3 x's at the bottom, so there's going to be 1 x left there. And then we'll have the square root of x to the 3 times the square root of 1 plus 7 over x. We can sort of distribute that square root to both of these expressions since they are multiplying. And then this I'm going to keep as is. Now this x to the square root of x to the 3, that's the same as x to the 3 to the power of 1 over 2. All right, there's like an imaginary 2 here if you just see a square root. And if you multiply these, you would end up with x to the power of 3 over 2. So I'm going to convert this, the square root of x to the 3, to be x to the power of 3 over 2. I usually like this here to be as a rational exponent. Usually it's going to be a whole number, but sometimes you'll have a rational exponent like this 3 over 2. And then this square root I'm going to just keep. We have square root of 1 plus 7 over x. Okay, so if we, basically I took this here, converted it to this form. And so if we continue this limit, we'll have the limit as x approaches infinity. I'm going to write these one by one. So this I'm going to write as that new format, x to the power 3 over 2 times the square root of 1 plus 7 over x. And now I'm going to follow the exact same process with these two. So we got the fourth root, I'll do it over here, fourth root of 6x squared plus 16x to the 12. Well, factor out the highest exponent, which is x to the 12, and we'd be left with 6 over x to the 10 plus 16. Right, if we divide both of these by x to the 12. I think that's right. Yeah, it is. And then we split these up, so we have the fourth root of x to the 12, and then we'll have the fourth root of 6 over x to the 10 plus 16. Now, x to the 12, the fourth root of that is like to the power 1 over 4, which would be x to the 3. 12 times 1 over 4 is 3. So this here would be x to the 3, and then we'd have the fourth root, 6 over x to the 10 plus 16. So this here is the exact same as that, and I'm going to write it as that. So we have x to the 3, then we got the 4th root of 6 over x to the 10 plus 16. And then this 8x cubed, we don't have to do anything with that, which is nice, so we just leave that. So that is our numerator, our new numerator, where we converted these. The 5x squared, don't got to do anything with that. And then this 3rd root of 7 plus 5x to the 6 minus 8x to the 9. This we're going to have to convert. So we would factor out x to the 9. So we divide this by x to the 9, this by x to the 9, then this by x to the 9. So we'd have 7 over x to the 9 plus 5 over x to the 3. X to the 6 over x to the 9 means that x to the 3 is left at the bottom. These cancel out, minus 8. And then this would be the 3rd root of x to the 9. Then we have the 3rd root of 7 over x to the 9 plus 5 over x to the 3 minus 8. And then x to the 9, the 3rd root of x to the 9 is like x to the 9 to the power 1 over 3, which is x to the 3. 9 times 1 over 3 is 3. So this here, this expression, we're going to write as that. X to the 3, which I just showed, times this here, the 3rd root of, let's erase this here, 7 over x to the 9 plus 5 over x to the 3 minus 8. Right? So a lot of work initially converting these two. But what's nice now is we follow the exact same process that we did before, where if we have multiple expressions in the denominator or the numerator, we divide everything by x to the highest power in the denominator. And notice that we have an x to the 2 and an x to the 3 here. Whatever's under these roots here in the denominator, we would ignore after we convert it to this format. We would just look at these two. So what's the highest exponent? X to the 3, meaning that everything now gets divided by x to the 3. Everything in the denominator, and then everything in the numerator as well. Okay, so now we would have what? The limit as x approaches infinity. So notice here, 3 over 2, we have, since we're multiplying, we could just look at this over this. They have the same base, both of these exponents. So x to the power of 3 over 2 over x to the 3, that would be, we could subtract the exponents. So 3 over 2 minus 3 is the same as like 3 over 2 minus 6 over 2, which would give us negative 3 over 2. So this would end up being x to the power of negative 3 over 2, which would be 1 over x to the power of 3 over 2. So there's a 3 over 2 left when we simplify these two at the bottom. And then the square root of 1 plus 7 over x, that stays as is. And then we got x to the power of 3 over 2 at the bottom. So this whole expression is that. Notice here, these x to the power of 3's cancel out, which is nice. So we're just left with the 4th root of, I think I have room here, x to the, or 6 over x to the 10 plus 16. Then notice that these x to the 3's cancel out, so we're just left with a plus 8 there. And this is going to be all over what? 5x squared over x cubed, that simplifies to 5 over x. And then notice these x to the 3's cancel out. So we're left with minus the 3rd root of all of this. 7 over x to the 9 plus 5 over x to the 3 minus 8. And now continuing on from here, if you remember, the limit brought this property up in a couple of videos back of a constant over x to the power r, where r is a rational number greater than 0. That's always going to equal 0. So notice that there's a bunch of expressions that are in this format. Notice this is in that format, this is in that format, this is in that format, this is in that format. What about this here? This one's kind of unique. So we got the limit as x approaches infinity. I'm going to kind of do this one on the side by itself. 1 plus 7 over x to the power 3 over 2. Well, notice that this 7 over x is going to go to 0. And so notice that we're going to have the limit as x approaches infinity of square root of 1, which is just 1. So this numerator is going to go to 1 over x to the power 3 over 2, which is in this format. Constant is 1, the r is 3 over 2, so we know this is going to go to 0. So this entire thing goes to 0. We just kind of had to show it in 2 steps. So this numerator goes to 1, right, because this goes to 0. Square root of 1 is 1, and then 1 over x to the power 3 over 2 as x goes to infinity. That whole thing is going to go to 0. All right, so now what do we have? What do we have left? So this whole thing went to 0. Here we'll have the 4th root of this goes to 0 plus 16. So we'll have the 4th root of 16 plus 8 over, this is 0. 5 over x is 0 minus the 3rd root of, this goes to 0, this goes to 0. So we have a minus 8 left there. And so the 4th root of 16 is 2 plus 8 over 0 minus the 3rd root of negative 8, negative 2. Right? And you got to make sure you put that negative 2 in brackets because we're subtracting that whole expression right there. And so we'd end up with 10 over 0 minus negative 2 is like 0 plus 2. These turn to a positive, which gives us 5. So that is the answer to this limit, and that's initially what I said at the beginning of the video. So pretty complex limit, lots going on there, but if you apply the same methods that we've been using in previous videos, then it's not too bad. It's just a lot of algebra, especially converting those square root expressions. But you follow the methods, you should end up getting 5.